Hi guys, welcome back to Schauer Thoughts. My name is Sarah Schauer. This is a podcast for left and right brainers, middle brainers, anyone with a pons medulla corpus callosum. If you got nerve, this is the podcast for you. What are we talking about this week? We are talking about some cool emerging research and some good legal news concerning some chemical companies getting sued. They're just desserts. But I do apologize if I seem a bit sad or out of it this episode. This past weekend, my dad had a stroke in his left cerebellum, which is part of your brain, and he was in the hospital and he just got out. But yeah, I don't know how to, I feel sad, but I have a unique relationship with my parents, so it's just a very unusual feeling. But my mom texted me that my dad had a stroke in his left cerebellum and he was having some like vision issues and debility issues and all this stuff, and I was like, that sounds like a vertebrobasilar insufficiency. And she was like, are you sure about that? I don't know. And I was like, well, I do love neuroscience. All last year I was reading about neuroscience, and now I've been in my year of medicine. And my dad, I talked about this before. Well, I talked about this a health condition before, does have atherosclerosis. And he is like constantly on his phone or computer. So there is also that, and mechanical compression on the veins in the back of his neck. And, you're talking about fourth ventricle. You're talking about, he's having coordination issues, double vision. He's like not coordinated. I would say that sounds like a vertebrobasilar insufficiency. And she's like, okay, I guess. And I was like, yeah. And so I was like, you should get, he's got like a CT scan, MRI. And, I was like, maybe you should do like a Doppler as well, because that tests for like the speed of blood flow, just because he also has some other overlapping conditions where it's just good to know. And she was like, yeah, thank you. But what frustrated me about this, besides all of it, is I was like, does Dad take like a GLP-1 or something? Because GLP-1s do help with atherosclerosis and also the other heart conditions he has. And she was like, yeah, he is prescribed a GLP-1, but I think the prescription is in the freezer. He hasn't taken it yet. And I was just like, why? And she's like, well, he hasn't kind of wanted to. I think he would take it if I also took my GLP-1. And I was like, you're also prescribed it? And she's like, yeah, I also have these like heart conditions. And then she started like talking about conditions that her mother had, or like her parents had, and then conditions that his parents had, what she inherited from her parents and what he inherited from his parents. I was like, okay, you didn't tell me any of this. And a lot of these are genetic. So now I kind of want to set up a doctor's appointment to test for some of these things. You really should have let me know. But then she was like, yeah, it's just I feel like he would take his GLP-1 if I took mine, but with my insurance, they said they don't cover it. And I was like, have you heard of this thing called paying out of pocket? And she's like, yeah, but, and I was like, no, but you can afford it. You're a doctor. He is a software engineer. You should have enough money to pay for this out of pocket. And so I just got to give her a little lecture on the importance of medication. Anyway, it's like weird. But if this episode is sad or I get weird, that's just why. But I did also want to record today because there was just some cool stuff happening and I saw some really cool research articles that I wanted to share with y'all. But that aside, I've been talking about nutrition and pesticides and insecticides and herbicides and all this stuff, and the EPA and the FDA and the USDA. And they're in a whole bunch of trouble right now because of Taylor Farms, the cyclosporin outbreak. Basically, the contaminated lettuce, they tried to pin it on Taco Bell, but then Taco Bell's like, we bought this from Taylor Farms, and then Taylor Farms sells to like Target, Walmart, like all these different places. So it's like, why is this such a big deal? Well, because when you have monopolies on certain industries, especially in agriculture, and like food is so important, this is why I'm talking about the FDA, the USDA, the EPA so much. They kind of just co-regulate everything in overlapping categories. And I had a breakdown on my Instagram story last night because the EPA, the USDA, and the FDA all alternate between scientific and legal definitions for things. Certainty, proof, truth, they mean different things legally versus scientifically. And why that's so annoying is science is very like specific. And when it comes to legal jargon, yes, it is quite specific, but also it's kind of like this word applies in this context, like, but it also could maybe be interpreted differently. It was just like, this is already so convoluted. I know that they're doing this on purpose. But yeah, the good news is that New York State is the state that is up to bat against chemical companies. So Attorney General James sues some of nation's largest chemical companies over toxic pollution from consumer products. 3M, DuPont, and others knowingly caused decades of PFAS pollution linked to cancer, birth defects, and other health problems. And this was the public statement put out July 9th, 2026. So this was literally like 2 weeks ago. New York Attorney General Lolita James today sued some of the nation's largest chemical and agricultural companies. 3M Company, IEDP Inc., the Chemours Company Inc., Chemours, Corvetta, and DuPont Chemours, DuPont, for contributing to decades of toxic PFAS pollution in New York through their use in consumer products. PFAS are known as forever chemicals because of their ability to persist in the environment without breaking down. Some PFAS are associated with an increased risk of cancer, birth defects, pregnancy complications, high cholesterol, hormone issues, and a wide range of other health problems. Attorney General James alleges that these companies manufactured, marketed, and sold PFAS that they knew to be toxic for use in consumer products. She further alleges that the companies deceived consumers and the public about their exposure to PFAS and the contamination of the environment and failed to warn the public about the risks of PFAS in consumer goods. Attorney General James is seeking a court order holding the companies liable for the environmental and public health damage they have caused, requiring them to fund cleanup efforts throughout New York and ordering them to properly warn consumers about their product risks. The lawsuit also seeks damages, restitution, and other financial penalties. Quote, big companies like 3M and DuPont knowingly sold toxic products that threatened New Yorkers' health and polluted our environment for decades. It's time for them to pay for the damage they caused, said Attorney General James. For far too long, our communities have unfairly shouldered the costs of protecting people from these toxic forever chemicals and cleaning up their contamination. I look forward to ensuring the companies responsible for PFAS pollution are held accountable. PFAS were first developed in the 1940s and were used in a wide variety of consumer products for their water and oil repellent properties. Companies such as 3M and DuPont began manufacturing and selling these chemicals for use in consumer products to create water and stain-resistant fabric treatments, water-repellent clothing, food packaging, non-stick cookware, cosmetics, and more. Regular use of these products release toxic PFAS into the environment and consumers' bodies, posing substantial environmental and health risks. Attorney General James alleges that the company knew early on that PFAS were toxic, persistent, and accumulated in humans, plants, and animals, yet hid this information from the public. As early as the 1970s, researchers at 3M had discovered PFAS in blood samples from the company's employees and the general public, and knew that their products were toxic. In 1981, DuPont secretly monitored 50 of its own female employees who were exposed to one of its PFAS products. Its data showed that 2 of the 7 pregnant workers who were exposed had babies with eye and nostril defects. Rather than inform its employees or regulators of the results, DuPont abandoned the study and continued to manufacture and sell that PFAS product. For everyone new here, like listening for the first time, I've been talking about women being banned from clinical trials in 1977 and then the Toxic Substances Act of 1976. We talked about how the 1980s were about, mass torts and personal injury lawsuits because of a whole bunch of chemicals that were now being tested and found out to be poisonous. And I have also linked Toxic Docs, and the University of California, San Francisco has a company database where you can go through like different industries like tobacco, alcohol, etc., agriculture, etc., so forth, and you can see unredacted corporate memos, and read about these companies did ahead of time know that a lot of these chemicals were toxic, and DuPont, 3M, Monsanto, now Bayer, they all knew, and you can find these on Toxic Docs or University of California, San Francisco, or actually, this is for anyone who's looking for like a really cool resource that's for free. So this one is a newspaper database, and I know with like newspaper database / archives, you always have to pay for it, and it's so annoying. However, there is a free one if you go to UCR, Center for Bibliographical Studies and Research. I'll include it below, but it's California Digital Newspaper Collection, and you can go through a whole bunch of old newspapers for free, and they have their archive goes back to, it's the 1800s. Like there's like deep 1800s in there. I've been going through there looking for newspaper articles to record an episode on the disability rights movement, and because it is Disability Pride, and so that's going to be next week's episode and probably the weeks after that. I've gotten off schedule because I've gotten so much into this environment stuff, but I'm looking into it. It's wild, the sheer amount of discrimination that people were just so open to stating to the public, written down, or a newspaper. Like it's wild. But if you're looking for a free newspaper database / archive, 5. That is one great one. Going back to New York suing, the lawsuit also alleges the companies knew that their products cause environmental damage. For example, in 1983, 3M scientists concluded that PFAS could pollute the water supply through wastewater. Yet for decades, 3M failed to conduct any of the environmental risk assessments its researchers recommended. Instead, the companies continued to aggressively produce, market, and sell chemical products containing PFAS they knew to be toxic while misleading consumers about their safety. Even when the companies phased out their own use of certain PFAS products, they failed to warn consumers about products that were still for sale or already in their homes containing these toxic chemicals. In other cases, harmful PFAS were merely replaced with similarly toxic compounds. Attorney General James alleges that the companies violated New York laws by producing, marketing, and selling products containing chemicals they knew to be harmful to New Yorkers' health and the environment for decades. The companies violated New Yorkers' rights to clean air and water by causing widespread environmental contamination. They violated New York's consumer protection laws by deceptively marketing their products as safe when in fact they contain toxic chemicals. The companies also engaged in repeated and persistent fraud, allowing them to illegally profit by failing to warn New Yorkers of the health and environmental risks of their products. Attorney General James is seeking a court order holding the companies liable for the environment and public health effects of their PFAS products and requiring them to fund cleanup efforts to rid communities of the toxic chemicals. The lawsuit also seeks to prevent the companies from selling any products containing harmful PFAS without adequate warnings and to end any misleading advertising. In addition, Attorney General James is seeking damages, disgorgement of all illegally earned profits, restitution, and other penalties. Attorney General James thanks the New York Department of Environmental Conservation and New York Department of Health for their assistance in this matter. This matter is being handled by assistant attorneys, and then they listed all the people who are involved. So yes, New York is the state that is now suing these big chemical companies. And I did talk about open secrets. I did also talk about like Good Jobs First. Good Jobs First, you can go through, it's like a database, and you find all these sort of like penalties that different, like a whole bunch of different companies have like accrued over time or like gotten over time. And I was talking about Monsanto a couple weeks ago, and Monsanto was just sued to all hell by Oregon for literally, the lawsuit said destroying the state of Oregon for the past 90 years. And so now it's like New York is up to bat where it's like, we're going to sue 3M, EIDP, the Chemours Company, Corvetta, and DuPont. And so it's like, it's just nice to see this type of stuff happening. The thing is I know that the legal system is absolutely, just Trump has gutted everything. And then the legal system in and of itself is just kind of like a nightmare health situation. But it's just nice to make these people stressed a little bit. So that was really good news. And then also, I'm just going to be going through some cool research that I've learned this week. And I'm going to be wrapping up on something I thought was really cool because, so in my year of neuroscience, I told everyone I wanted to integrate rest and digest. Your parasympathetic nervous system is like rest and digest and, reset, where it's sleeping and then digestion. And it kind of like, it's just really cool. And so now I've gotten into my year of medicine. And so what I'm going to talk about after this article, maybe a little bit with this article, but after this article, I'm going to like show you what I mean by how I want to integrate rest and digest, because last year was all neuroscience, which is very focused on the electrical aspects, obviously, because when it comes to like electrical impulses and like all these stuff, but the body, a lot of people focus more on the chemistry aspect. Obviously, it's a hybrid system. It's an electrochemical system, but it seems like what I'm learning through body that more people are focused on the chemistry, and with the head and the brain, a lot more people are focused on the electrical of it all. And so after this article, I want to show you what I mean by integrate, rest, and digest, and how it's so cool how the chemical and the electrical complement themselves so well. So this is new research. Researchers discovered the eye's hidden cleanup system, and this is from July 19th, 2026. Many of the world's leading causes of irreversible blindness, including glaucoma and age-related macular degeneration, share a common problem: the buildup of fluid, waste, and inflammatory debris in the back of the eye. If you're new here, I'm kind of obsessed with the body's way of cleaning out waste, and now you're going to be like, so you're interested in pooping? To a degree, yes. My favorite type of doctor is a gastroenterologist. I am also reading this book called A Silent Fire: The Story of Inflammation, Diet, and Disease by Shilpa Ravella, who is a transplant gastroenterologist, and love it. I'm actually going to quote it later for something. But the thing is when it comes to the lymphatic system in your brain, there's a lymphatic system, which is outside brain. Glymphatic system is inside brain. And so the glymphatic system cleans your brain for like waste buildup at night when you sleep. It's kind of like a little washer machine. And so they discovered this part of the glymphatic system in the eye, which is so cool. However, for decades, scientists have lacked a clear understanding of how the eye clears the waste away. New research from the University of British Columbia and the University of Toronto has identified what appears to be a missing piece of the puzzle, a previously unknown waste drainage system at the back of the eye. The hidden circulatory pathway called the posterior ocular lymphatic outflow, or POLO pathway, it's part of the lymphatic system, provides a route for fluid and waste to exit the eye and enter the body's lymphatic system. The retina is one of the most metabolically active parts of the body, constantly generating byproducts that need to be cleared, said Dr. Neeru Gupta, professor and head of UBC's Department of Ophthalmology and Visual Sciences. This discovery helps explain how the eye flushes this waste and promises to transform how we think about and treat a range of eye conditions. And then it says a foundation for future therapies, diseases like glaucoma, macular degeneration, and retinal disorders are associated with fluid buildup, accumulation of metabolic waste, and tissue stress and inflammation. Age-related macular degeneration alone affects approximately 2.5 million Canadians. The discovery of the POLO pathway suggests there is a natural system responsible for clearing this material and opens new opportunities to harness this system to treat disease. This gives us a whole new framework for understanding the diseases and a potential target for therapeutics, Gupta said. The question now is, how can we enhance or exploit this clearance system to treat or prevent disease? Hiding in plain sight. For more than a century, the eye was thought to lack a lymphatic system. This is what I actually don't understand. From what I've read in a lot of medicine books and just a lot of books in general, there's so many the casual throw out of vestigial organs. So vestigial is basically something that has become unnecessary through evolution. It's just kind of stuck around. Doctors or people discovering, they're we thought this organ was useless, and then we realized the pancreas is needed. It's why would you think that if it's, I don't know, maybe I'm just a tinkerer, but whenever you disassemble something, I would never assume without knowing the full system and how it works that something is negligible, that it's defunct, it doesn't work, it's vestigial, we could just throw this away. You just took it apart. Why would you think, they thought the thymus was decorative. And I was they said that we thought the eye lacked a lymphatic system. Well, okay. I mean, it's, yeah, but so many times in medicine, they're we thought the brain was immune system privileged, we thought it was its own collective. Why would you assume that? I don't know. I would assume that everything is kind of connected in the body until proven otherwise. I just don't, whenever I read books from medical professionals or a lot of scientists, I read their methods on their research section to try to get in their headspace. But even after that, I'm why did you make this assumption in the first place? And then I try to look into the context of it, and I'm this is still not adding up. It's not for all of it, but just a lot of times I'm I genuinely can't follow what you're saying here. Anyway, that's just something else. Okay, so for more than a century, the eye was thought to lack a lymphatic system, which is present in nearly every other organ and helps to regulate fluid, remove waste, and support immune function. Gupta and Dr. Yenny Yusil, professor and director of ophthalmic pathology at the University of Toronto, began challenging that idea in 2009 with the discovery of a lymphatic-related drainage pathway at the front of the eye termed the lymphatic pathway. Yet the back of the eye, where many blinding diseases are rooted, has remained largely unexplored. The retina is responsible for vision, and it's also where many of the most serious vision loss diseases occur, Yusil said. Understanding how this part of the eye maintains a balanced environment and flow of materials is critical. To uncover the POLO pathway, the team used advanced imaging in mice, combining MRI, near-infrared fluorescence, and microscopic analysis. They introduced fluorescent tracer molecules into a thin space at the back of the eye and tracked their movement in real time. This allowed them to identify small lymphatic vessels in the choroid, a thin layer beneath the retina. Fluid drained from the back of the eye into surrounding orbital tissue, and within minutes reached nearby lymph nodes that link the eye to the broader lymphatic system. Because lymphatic vessels in the choroid were thought not to exist, the team used multiple techniques to demonstrate both their presence and function. Added Yusil, a pathologist scientist at St. Michael's Hospital, we were surprised to see such a direct route for fluid to leave the eye and connect with the lymphatic system. It suggests the back of the eye has an active clearance pathway, which could play an important role in removing fluid, proteins, and inflammatory material that build up in disease. Further research is needed to understand how the lymphatic pathway operates in humans and how it could be targeted with therapeutics. But the research say it could one day lead to improved drug delivery to the back of the eye, new therapies that enhance fluid clearance, and deeper insight into how pressure, inflammation, and fluid dynamics contribute to vision loss. This is a foundational discovery that shows the eye is not a closed system, as we previously thought, Gupta said. It gives us a new map, a new mechanism and a new set of questions to explore. And that is incredible. Yeah. What's interesting is that the eye, when it comes to like the senses that have been studied, vision is probably the most studied sense. And so it's like, well, I wonder, has anyone else noticed it? Like sometimes I don't understand the assumptions that a lot of people have in like med school or research, but I love this. I also love that they said that they started in 2009 and now it's 2026. And so it's like, yeah, the dedication is so impressive. And the love of the game, but the love of the eye, just to keep going. Ooh, so this next research that I was looking into is not quite new. It was something that was published around like 2021 to 2023, but I just recently found out about it. And I've told y'all that I really want to integrate the rest and digest system. And with this new information and me also reading A Silent Fire and getting to macrophages, which are part of the immune system, I get to do that right now. And it's going to be so much fun. So it's going to be a long build up. So I do apologize if you're like, I think I'm going to get lost. That is totally fine. I will try to explain it as slowly as I can because there is so much information, but it's super cool. The information I just learned, and then I'm going to go through the whole explanation and then combine it with 2 new pieces of research. And I would appreciate it if you could hear me out and also go ahead and research what I'm saying. I will give you all the sources linked below and the books that I used, but I'm excited and hopefully you see what I'm saying by the end of this. And then everyone else who is in research or medicine or chemistry, anything like that, if I do mispronounce a chemical term or name, I would like some grace. I am self-teaching and I do not have an internal monologue. And if I have to look up the pronunciation of each of the words that I read, I would have to pause every other page to like listen to someone say it out loud. And so I do appreciate everyone who is like super understanding when it comes to pronunciation. But yeah, we're going to talk about how macrophages can taste and smell. So this is an article from the La Jolla Institute for Immunology. Macrophages in the artery wall smell their surrounding. Immune cells can sniff out octanol in blood, triggering dangerous inflammation and atherosclerosis. La Jolla, California. An artery is not like a nose, or is it? Scientists at La Jolla Institute for Immunology have discovered that immune cells in arteries can sniff out their surroundings and cause inflammation. Smelly molecules can be pro-inflammatory, says study leader Professor Klaus Ley, MD, a member of the La Jolla Institute Center for Autoimmunity and Inflammation. The new study published in Science shows that this inflammation can lead to cardiovascular disease and atherosclerosis in mice. The researchers reversed this inflammation by blocking immune cells called macrophages from sensing a compound called octanol. Everyone has a small amount of octanol in their blood, but La Jolla Institute scientists have shown that people with markers of cardiovascular disease, such as high LDL cholesterol, also have higher levels of octanol. This extra octanol can end up in blood due to diet or a phenomenon in cells called oxidative stress. The human nose is already good at smelling octanol. Ley describes it as a warmed over chicken kind of odor, like chicken that is not so nice anymore, he says. A 2019 study spearheaded by La Jolla Institute scientific associate Sarah McArdle, PhD, was the first to show that macrophages in blood vessel walls also have some of the olfactory receptors needed to, quote, smell molecules. In 2020, LJI scientists were the first to report that these macrophages can sense octanol thanks to an olfactory receptor called OR6A2. Macrophages are some of the most important cells in our immune system, says study first author Marco Oriciani, PhD and instructor at LJI. They are constantly checking for signals. We could say they sniff their environment and respond. The new study is the first to show precisely how sniffing out octanol can boost inflammation in the arteries. Oriciani tested the effects of injecting octanol into normal, quote, wild-type mice and into mice where the gene for the mouse macrophage receptor, OLFR2, which corresponds to OR6A2 in humans, was deleted. By comparing these mouse groups, Oriciani found that inflammation gets much worse as the OLFR2 receptor senses octanol. Over time, the arteries even begin to develop the lesions seen in atherosclerosis. The researchers then used a molecule called citrol, which has a lemon-like odor known to block this mouse olfactory receptor, and saw that inflammation went down. By making macrophages blind to octanol, they reversed the disease progression. Ley and Oriciani think it may be possible to block OR6A2 in humans too. These receptors are very well known as drug targets, says Lay. In fact, most drugs on the market today act on this type of receptor called GPCR. Oriciani's work was supported by La Jolla Institute's Tully and Ricky Family Spark Award, which makes it possible for early career LJI scientists to lead, quote, high-risk, high-reward projects as they launch an independent research career. And so there's more about the grants. The researchers are now investigating the jobs of other olfactory receptors found on macrophages. They're also examining how OR6A2 operates in humans. Oriciani plans to continue studying atherosclerosis, but he's curious whether olfactory receptors may play a role in metabolic disease, such as type 2 diabetes. This study is just the hint of something new, he says. It's opened up years of research ahead of us. Oh my God. Okay, so if you're new here, in my year of neuroscience, my favorite sense of all time, sense, is olfactory, and closely tied to olfactory is taste. So smell and taste are connected. They are both chemical senses. Hearing and vision, they developed much later in evolution, and so the oldest sense you have is your olfactory sense, followed closely by taste. And so this is really cool. And I just want to give more backgrounds on the OR6A2 gene. So this is going to be a whole long spiel. If I lose you at any point, that's totally fine. I just am excited to say what they were talking about. So the OR6A2 gene is an olfactory receptor gene on chromosome 11 that dictates how you perceive the flavor of cilantro. If you have a specific variation of this gene, your nose is hypersensitive to aldehydes, chemical compounds found in both cilantro and soap, causing the herb to taste overwhelmingly soapy or metallic. Why I'm also excited about this when it comes to genes that involve olfactory or taste is because I'm rereading this book by Noah Whiteman called Most Delicious Poison, The Story of Nature's Toxins from Spices to Vices. And Noah Whiteman is a professor of evolutionary biology at the University of California, Berkeley. And so within this book, he's talking about different deadly daisies. And so it's how a lot of nature's toxins, the dose does make the poison. He, however, is talking about the TAS2R38 gene, which is expressed on our taste buds, which is responsible for bitter taste. So this one is talking about the OR6A2 gene. It's an olfactory receptor that dictates how you perceive the flavor of cilantro, and cilantro can be soapy or metallic. Now, when you say something is metallic, that's most likely going to go to any sort of bitter receptors. This is a follow-up article from Quantum magazine, their immunology section. Cells that taste danger set off immune responses. Taste and smell receptors in unexpected organs monitor the site of the body's natural microbial health and raise an alarm over invading parasites. And this is from a couple years ago. When the immunologist Dabrowski Herbert at the University of Pennsylvania looked deep inside the lungs of mice infected with influenza, he thought he was seeing things. He found a strange-looking cell with a distinctive thatch of projections like dreadlocks atop a pear-shaped body, and it was studded with taste receptors. He recalled that it looked just like a tuft cell, a cell type most often associated with the lining of the intestines. But what would a cell covered with taste receptors be doing in the lungs? And why did it only appear there in response to a severe bout of influenza? Herbert wasn't alone in his puzzlement over this mysterious and little studied group of cells that kept turning up in unexpected places, from the thymus, a small gland in the chest where pathogen-fighting T cells mature, to the pancreas. Scientists are only just beginning to understand them, but it's gradually becoming clear that tuft cells are an important hub for the body's defenses precisely because they can communicate with the immune system and other sets of tissues, and because their taste receptors allow them to identify threats that are still invisible to other immune cells. Researchers around the world are tracing the ancient evolutionary roots that olfactory and taste receptors, collectively called chemosensory receptors or nutrient receptors, share with the immune system. Like I was talking about, taste and smell are chemical senses, and they're picked up by chemoreceptors, and it's also chemoreceptors also are nutrient receptors. And so a flurry of work in recent years show that their paths cross far more often than anyone anticipated, and that this chemosensory immunological network plays a role not just in infection, but in cancer and at least a handful of other diseases. I didn't mean to smile when I read that. This is just so cool because I can't wait to explain it. I'm sorry. Oh, well, not explain this, but okay. This system, says Richard Loxley, an immunologist at the University of California, San Francisco, helps direct a systematic response to potential dangers throughout the body. Research focusing on the interactions of the tuft cell could offer a glimpse of how organ systems work together. He describes the prospects of what could come from the studies of these receptors and cells as exciting, but cautious that we're still in the very early days of figuring it out. Not merely taste and smell receptors. One of life's fundamental challenges is to find food that's good to eat and avoid food that isn't. Outside of our modern world of prepackaged food on grocery store shelves, it's a perilous task. Taking advantage of a new type of food could mean the difference between starvation and survival, or it could mean an early death from accidental self-poisoning. Chemosensory receptors help us make this distinction. They're so essential that even single-celled bacteria, such as E. coli, carry a type of this receptor. Despite the near universality of these receptors and their centrality to survival, scientists didn't discover the big family of genes that encode for olfactory receptors until 1991, with the ones for taste receptors following in 2000. The olfactory receptor discovery brought the researchers Richard Axel and Linda Buck a Nobel Prize in 2004. Olfactory receptors and taste receptors for bitter, sweet, and umami, which is savory, are all part of a large family of proteins called G-protein coupled receptors, GPCRs, that are embedded in cell membranes. Although the precise details vary from receptor to receptor, when a GPCR binds to the proper molecule, it sets off a signaling cascade within the cell. For taste and olfactory receptors in the mouth and nose, this cascade causes neurons to fire and enables us to recognize everything from the rich sweetness of a chocolate chip cookie to the nose-wrinkling stench of a passing skunk. The discoveries of these receptors were monumentous, groundbreaking advances, says Jennifer Pletsnick, a physiologist at Johns Hopkins, but in her view, labeling them as olfactory and taste receptors rather than as chemosensory receptors entrenched the idea that they function specifically and exclusively in smell and taste. If scientists found signs of these receptors in cells outside the nose and mouth, it was easy to write them off as a mistake or anomalies. She herself was shocked to find an olfactory receptor called OLFR78 in kidney cells, a finding that she reported in 2009. Oh my God. Sorry. I'm so excited. I think I even famously said something to my postdoc advisor like, I don't even know that I can trust this data, Pletsnick recalled. Olfactory receptors in the kidney? Come on. This wasn't the first time these receptors had shown up in unexpected tissues. For example, in 2005, the University of Liverpool biochemist Soraya Shirazi-Biche showed in a paper published in Biochemical Society Transactions that taste receptors could be found in the small intestine as well as the mouth. Their presence was surprising, but it made a certain sense that the intestine might use a taste receptor to monitor the food it was digesting. But then in 2010, the laboratory of Stephen Leggett, who was then at the University of Maryland School of Medicine, reported that smooth muscle in the airways of the lungs expresses receptors for bitter taste. Moreover, they showed that these receptors were involved in a dilation response of the airway that helped to clear out obstructions. Yes, you do have bitter taste receptors in your lungs, and when you cough, when you smoke, those are your bitter receptors in your lungs. Receptors for sweetness also turned up on the cells lining the airways. In 2012, a researchers group led by Herbert's colleague Noam Cohen at the University of Pennsylvania found that the sugars coating the respiratory pathogen Pseudomonas aeruginosa activated these receptors and caused the cells to beat their hair-like cilia more rapidly, a process that can sweep away invading bacteria and prevent infections. Meanwhile, Pletsnick and her colleagues had continued to study the role of the OLFR78 receptor in the kidneys. They demonstrated in 2013 that it responded to molecules secreted by intestinal microorganisms, and that signals from that response helped to direct kidney secretion of the hormone renin, which regulates blood pressure. Other lab findings, similar things in other tissues, was both very encouraging and very exciting, Pletsnick said. These studies and a torrent of others from labs around the world drove home the message that these seemingly misplaced olfactory and taste receptors serve important and often vital functions. And a theme common to many of those functions was that the chemosensory receptors often seem to be alerting tissues to the presence and conditions of microbes in the body. In hindsight, the application for the receptors made a lot of sense. For example, as Herbert notes, being able to, quote, taste and smell minute traces of pathogens gives the body more chances to respond to infections before microbes overwhelm the host defenses. So that is about tough cells, but macrophages can also, they have chemoreceptors that can both taste and smell. So it's just really cool. A lot of inside your body beyond just your mouth and your nose can taste and smell. And that makes sense when you think about the first senses to develop in an evolutionary sense. So the first article talked about the OR6A2 gene, the olfactory gene, that dictates how you perceive the flavor of cilantro. If you have a specific variation of this gene, your nose is hypersensitive to aldehydes, which is a chemical compound found in both cilantro and soap, causing the herb to taste overwhelmingly soapy or metallic. So then, a break from those two articles, we're going to be reading from A Silent Fire, The Story of Inflammation, Diet, and Disease by Shilpa Ravella. I am loving this one. If you guys are watching on YouTube, I have annotated the crap out of this. In the chapter, A Sense of Strangling, I'm on page 62. So delving further into the mechanism of atherosclerosis, Libby found that low-density lipoproteins, LDLs, or bad cholesterol particles, made their way into the lining of coronary arteries, where they sometimes injured the endothelium, leading to abnormal growth of underlying smooth muscle cells and other tissues, just as Russell Ross had previously described. But they also incited an inflammatory response. Just as a germ or traumatic injury can inflame a body part with subsequent redness, heat, swelling, and pain, LDL can inflame a coronary artery. LDL-mediated injury transforms endothelial cells cells, much like cytokines do, disabling their original function and turning them into inflammatory powerhouses. These cells weaken their tight protective barrier, becoming leakier. They fail to secrete enough nitric oxide, a critical molecule that calms inflammation, widens blood vessels, and keeps blood flowing smoothly, warding off blood clots. Endothelial cells in this setting instead recruit immune cells and churn out inflammatory mediators. A dangerous circular path ensues. Inflammation begets blood clots, and blood clots amplify inflammation. As Libby and other scientists began to bear inflammation's critical role in atherosclerosis, they found macrophages at work in every stage of the disease. Mechnikov's policemen, which is the macrophages, once ignored as vestigial scavengers of the innate immune system, equipped to fight ancestral killers like infections and wounds, landed at the center of humanity's deadliest modern diseases. Macrophages, which make up most of the immune cells involved in atherosclerosis, voraciously gobble up LDL particles. Ultimately, they became so packed with fatty droplets that they appear foamy under a microscope, earning them the name, quote, foam cells, which have been recognized as a hallmark of atherosclerosis since Virchow's day. Macrophages are sophisticated warriors able to assemble specialized platforms called inflammasomes that spew out dozens of inflammatory molecules. And then it talks about it more. This is the important part. Ultimately, the macrophages became so packed with fatty droplets that they appear foamy under a microscope, earning them the name foam cells. And we're going to talk about why that is important. My thing is that you're talking about fatty tissue and you're talking about foaming and you're talking about the immune response. Foam-like are foam cells soap? And someone listening to this is going to be like, no, you stupid girl. Foam cells aren't soap. They're like soap though. The thing is these foam cells, they sound like soap, right? We're talking about fat. You need fat to make soap. And with the previous gene that I was talking about, the OR6A2, it's an olfactory receptor gene that dictates how you perceive the flavor of cilantro. If you have a specific variation of this gene, your nose is hypersensitive to aldehydes. Aldehydes are also found with soap, chemical compounds found in both cilantro and soap, causing the herb to taste overwhelmingly soapy or metallic. So these macrophages, they eat so much fat and they're called foam cells. And I'm like, oh, this sounds like soap. Okay, so we're going to do a sort of background information on plant and soap and this soapy taste. Saponins are naturally occurring plant compounds, glycosides, famous for their ability to create stable soap-like foams. Plant-derived saponins are naturally occurring plant-based compounds known for their unique foaming properties and amphiphilic structure, meaning they both have water-loving and fat-loving components. Saponins are found in over 90 plant families. They get their name from the Latin word sapo, meaning soap, as they produce a rich, soapy lather when shaken in water. Cilantro leaves contain naturally occurring compounds called saponins, along with a high concentration of aldehydes, which are volatile organic compounds. These same molecules are responsible for the distinctive aroma of soap, the waxy smell and taste. Again, cilantro has a naturally waxy texture and a, quote, waxy flavor because cilantro leaves contain aldehydes such as E2-decenol and E2-dodecenol. And this is going to build up to my point. And so this is talking about soap and aldehydes in plants. However, aldehydes can also be made in the body. Aldehydes can form in the body through lipid peroxidation, the degradation of lipids and fats by oxidative stress and sugar metabolism. Common reactive aldehydes associated with vascular damage, like atherosclerosis, are malondialdehyde, MDA, and 4-hydroxynonenal, HNE. There's also external sources like cigarette smoke and toxins that can introduce aldehydes directly into the bloodstream. Atherosclerosis is a lipid-driven inflammatory disease where plaque, which is sticky, a waxy substance, builds up inside your arteries. Reactive aldehydes, which are highly toxic, chemically reactive compounds, play a major role in driving this process. So reactive aldehydes are crucial to atherosclerosis progression, which is like a vascular disease, and there's like a sticky substance inside, like it's like a plaque inside your veins. Now that's the human body. Soap itself is made via saponification. The chemical reactions take place that break down lipids. During this process, various aldehydes are formed as byproducts. These byproducts products compounds give unscented traditional soaps their distinct, slightly pungent, and waxy aroma. Again, soap fundamentally relies on an acid-based chemical reaction, which, yes, is known as saponification. Moving back to humans, there's also something called acidosis in humans, and it's where your body accumulates too much acid or loses too much base, dropping blood pH below the normal 7.35 to 7.45 range, and it's divided into metabolic acidosis, kidney or digestive issues and excess acid, as well as respiratory acidosis, which involves lung and breathing issues. So going back to metabolic acidosis. Metabolic acidosis happens when the body produces too much acid. The kidneys fail to filter it out, or the digestive tract loses too much bicarbonate. There's diabetic ketoacidosis, DKA. It occurs in uncontrolled diabetes when the body burns fat for energy, producing acidic ketone bodies. There's lactic acidosis, which is a buildup of lactic acid, often triggered by intense exercise, seizures, severe infections like sepsis, liver failure, or prolonged lack of oxygen. And then also included with metabolic acidosis is chronic kidney disease, CKD, or acute kidney injury, AKI, which prevents the kidneys from properly filtering and excreting excess acids. Then there's gastrointestinal loss, where severe diarrhea or laxative overuse can cause a loss of bicarbonate, which is a base that neutralizes acid. And then there's also toxins like poisoning from methanol, ethylene glycol, which is antifreeze, or an overdose of aspirin. And you're like, this is a lot, but I swear it's so cool how it comes together. So that's metabolic acidosis. And then there's respiratory acidosis. Respiratory acidosis develops when the lungs are unable to effectively remove carbon dioxide, which acts as an acid from the body due to depressed breathing or poor lung function. You see respiratory acidosis with chronic lung disease and conditions like chronic obstructive pulmonary disease like COPD, emphysema, and asthma. There's also medication overuse. Sedatives, opioids, and sleeping pills can suppress the brain's drive to breathe. And then there are also neuromuscular conditions, which involve weakness in the chest muscles or nerve issues affecting breathing, something you would see with muscular dystrophy or ALS. And then there's also some chest trauma and deformities that can cause it, like kyphosis, because the condition restricts lung expansion. So that was respiratory acidosis. Acidosis, metabolic, and respiratory acidosis. When you say metabolic and respiratory, what senses are you typically talking about? If it's metabolic, it's most likely something being eaten, consumed, taste. And then respiratory is going to be like breathing, which is involved, it's like a lot of smell and mouth. And so taste and smell related processes. I want to point that out now because when it comes to what's happening in the body is basically like, the factory is working, but then the factory translates it up to the brain. So if you're like, why are you putting something as massive as metabolism and respiratory into these two, what you would consider smaller categories, even though they're not? It's because we're going to integrate what's happening into the body now into the brain. So metabolic, you're thinking a lot of like taste. Respiratory, you're thinking like smell and breathing. So we have chemo senses that are important to understand here, and acidosis in two different contexts and what can cause them. So taste and smell are distinct chemical senses, but together they create the experience of flavor. So flavor can only happen when smell and taste come together. And if you're saying something is the experience of flavor, that is the conscious experience. So these two things are joint. While you do taste and smell in your head, you still have your nasal cavity, your gustatory, sort of your mouth leading down to your body. So when smell and taste come together, they create the perceptual experience of flavor. The experience of flavor concerns several brain regions. There is the primary gustatory cortex, which is located in the insula, the frontal operculum, which is the main destination for taste signals like sweet, salty, sour, bitter, umami, sent from your tongue. It identifies the specific quality and intensity of what you are tasting. Now, when it comes to gustatory, like eating and tasting, a lot of people think that it's just, it's just your tongue that tastes. However, your entire gastrointestinal tract, the back of your nose, all the way down, it's all lined with chemoreceptors. It's going to activate chemically, probably not as an extreme taste as if you're tasting it on your tongue. There's also something called retronasal smell. How you're actually able to experience a lot of flavor is through heating up what's in your mouth by you're breathing out, and then that breath heats up what's on your tongue, and now you're tasting. It's called retronasal smell, and you're able to taste what you're eating. 80% of flavor is going to be smell. So again, the experience of flavor, conscious experience of flavor. Oh my God, I love love the way this tastes, or ew, that tastes like dookie butt. That concerns several brain regions. Primary gustatory cortex, located in the insula. And so, oh my gosh, this is so cool how, like, the thing is the insula also deals with empathy and disgust. And so it deals with literal, visceral disgust, but it also deals with moral disgust, which is like sort of a cognitive aspect of disgust, as whereas this is the visceral, coming from the visceral, like knee-jerk reaction. Oh, ugh, you know? So it's all getting kind of integrated in the insula. Okay, sorry. We got to keep going. And then also concerned with the experience of flavor is the primary olfactory cortex, which is located in the temporal lobe where smell is processed. Up to 80% of what we call flavor actually comes from aroma. Odors released while chewing travel up to the nasal cavity, and the smell data merges with the taste data to create full flavor. However, 80% smell. Also included in the experience of flavor in the brain is the orbitofrontal cortex, OFC. It is the ultimate multisensory integration center. It combines the signals from your taste buds, smell receptors, and even texture or temperature from the trigeminal nerve to create the unified experience of flavor. It also assigns a reward value, which determines how much you enjoy the food. So if you're like, oh, this is good. This is good shit. And then also just included with the experience of flavor, because she's always included, is the amygdala. She's in everything. The amygdala ties your food experience to emotion and memory. Just wrapping that up. Experience of flavor concerns several brain regions. Primary gustatory cortex, located in insula. Primary olfactory cortex, which is located in temporal lobe. If you're like, I have no fucking idea where these are located in the brain, that's totally fine. If the location is important, I will mention it, and I will soon mention it. So you can understand that. As someone who's like visually, spatially oriented, I get it if you're like, I can't retain all these. It's totally fine. You're not going to be tested on this. And then also there's the orbitofrontal cortex and the amygdala. Both olfactory, smell, and gustatory, taste receptors are found on immune cells, where they act as chemical sensors to detect pathogens, initiate inflammation, and regulate immune responses. So, some immune cells, they have chemoreceptors. They can smell, like they have olfactory and gustatory, which is taste, receptors found on the immune cells. And so when you have those two things coming together, maybe your cell is kind of somewhat experiencing flavor. It's not probably the same flavor where, we recognize it, but it's a flavor where your immune cell is like, oh, good. Ugh, don't like that. With those two receptors coming together on an immune cell, it can react as if there is a flavor. And so these chemical sensors together detect pathogens, initiate inflammation, and regulate immune responses. So say like you did eat something bitter that you shouldn't have, then the bitter receptors taste, smell, oh crap, that is toxic, poisonous, and now your immune system is like, guys, this is gross and I think it's going to hurt someone, and then we all kind of launch an attack on it, kind of wall it off, okay? So macrophages specifically connect to the primary olfactory cortex and the broader central nervous system through anatomical, immunological, and biochemical pathways. Since macrophages are immune cells and the primary olfactory cortex is brain tissue, their interaction relies upon the olfactory nerve, cerebral spinal fluid, and the blood-brain barrier. That's macrophages, part of the immune system. They're immune cells, and the primary olfactory cortex is brain tissue. How are they going to talk? Their interaction relies upon the olfactory nerve, cerebral spinal fluid, and the blood-brain barrier. Blood-brain barrier protecting the brain. Cerebral spinal fluid is the fluid in your spine, and then it washes your brain at night. And the olfactory nerve concerns smell. That's macrophages. Microglia are the brain's resident macrophages. Macrophages specifically patrol the periphery, like the nasal cavity and the rest of the gustatory tract. So microglia are like brain macrophages. They're like, the blood-brain barrier is super selective with who they let in. Microglia is like immune system in brain, macrophage periphery, outside. Microglia in the central nervous system continually survey the microenvironment of the primary olfactory cortex to maintain tissue homeostasis and respond to injury. They are also involved in immune signaling. They're like doing macrophage's job like in olfactory cortex, like in brain. And so moving outside of brain into the periphery, if macrophages, not microglia, in the nasal mucosa or gustatory tract detect a virus like SARS-CoV-2, like COVID, or an injury, they release inflammatory molecules, cytokines or chemokines, and those circulating signals trigger microglia in the olfactory bulb and primary olfactory cortex to activate, which leads to neuroinflammation or structural alterations. So while your nose hole and your mouth are in your head, they're not like in your brain. They do immediately connect. There's like the cribriform plate that separates your nose hole from, your actual brain, but they have to go through like an actual plate to get into your brain. So the macrophages in your nose or your mouth are like, oh fuck, there's COVID. They release the inflammatory molecules, cytokines, chemokines. They start to circulate in the blood. The blood's like going everywhere because, it's blood. And then those, since they can... blood-brain barrier, microglia on the inside, they're like, what? What's that? There's COVID out there. And so those microglia in the olfactory bulb and primary olfactory cortex activate, and that leads to neuroinflammation or structural alterations in your brain. Thank you so much for your patience. This is going to bring in some research I discussed last week. Inflammation forces the brain stem cells to halt neurogenesis. And the summary of this is a new study demonstrated that introducing inflammatory signaling molecules directly into human hippocampal stem cells brings new neuron production to a dead stop. Instead of simply dying or becoming damaged, the brain's neural stem cells actively abandon their regenerative responsibilities, transforming into an immune alert state that actively fuels localized neuroinflammation. Background information on neurogenesis. Neurogenesis is the biological process by which neural stem cells divide and differentiate to produce new functional neurons. It is highly active during embryonic development, but continues throughout adulthood in specific brain regions, notably the hippocampus, playing a critical role in learning, memory, and cognitive flexibility. Okay, so if there is inflammation, if there is neuroinflammation, right? Macrophages set off microglia. There's neuroinflammation. We need to address this. If there's localized neuroinflammation with the hippocampus, which is hugely involved in learning, memory, and cognitive flexibility, then neurogenesis is halted. They're like, immune alert, stop producing something new. There is an infection and like someone broke into the laboratory. We have to go address them, beat them up, take them out of here. Stop making neurons, pause. We're all going to kind of go and like get this guy out of the lab. So this is how neurogenesis works. Adult neurogenesis takes place primarily in two canonical regions of the brain. The hippocampus, which is crucial for spatial navigation and forming new memories. New neurons born here integrate into existing circuits. Adult neurogenesis also takes place in the olfactory bulb. Important for processing odors, in this region, new neurons migrate from the subventricular zone to support sensory processing. The entire maturation process from a stem cell division to a fully integrated neuron forming synapse takes about 2 months. If y'all have been here since last year, you know what I'm about to say. Smell and memory are basically one. Smell is the only sense that does not get filtered through the thalamus. Vision, sound, taste, touch, it all goes through the thalamus. Stands without smell. Now, the hippocampus and the olfactory bulb. Like I said, why smell and memory are one. Smell, olfaction is the oldest sense you motherfucking had. We were basically, when we were embryos and then we developed in the womb, we were basically one long tube from mouth to anus. And then we developed a brain and stuff like that. So smell and memory are basically one. And now this is where location really does matter. In the brain, the olfactory nerve, amygdala, and hippocampus are side by side, literally separated at most by 3 synapses. I mean, they are olfactory bulb. Imagine you're seeing me right now. I have this book called The Human Brain Book by Rita Carter. I got it on a date with my butch. But this is one of my favorite pages. It's perceiving smell. You cannot see this. But like I said, neurogenesis happens in 2 main locations, the hippocampus and the olfactory bulb. Now, when you talk about the olfactory nerve is different from the olfactory bulb, but olfactory nerve and bulb are connected intimately, deeply. So in the brain, the olfactory nerve, amygdala, hippocampus are side by side, like in a row. Imagine you're driving down a street and you see 3 houses literally right next to each other, like maybe 10 feet between each of them. So they are neighbors. And I'm on page 85 of this brain book. It says olfactory bulb, and then right after it is olfactory nerve. It carries signals from the olfactory bulb, closely linked to hippocampus and amygdala. The house beyond quote, house beyond the olfactory nerve is the amygdala. Only 2 synapses separate olfactory nerve from the amygdala. They are side by side. And then right behind the amygdala, deep in the center of your brain, is the hippocampus. Only 3 synapses separate olfactory nerve from the hippocampus. So when I tell you olfactory bulb, olfactory nerve, amygdala, hippocampus, neurogenesis is happening in the olfactory bulb and the hippocampus. Between olfactory bulb and hippocampus is olfactory nerve and amygdala. So there's going to be a lot of emotion since the amygdala is like, hey. So it's like receiving the scent, then it goes through the emotion center, and then it goes to the memory center. Hippocampus, deep in the brain. Circling back to microglia and neurogenesis. We talked about neurogenesis happens in olfactory bulb, hippocampus, very tight neighborhood, deep within your brain, okay? Microglia and neurogenesis have a highly dynamic two-way relationship. Microglia, like I said, are the brain's resident immune cells. They are also essential sculptors and regulators of new neuron generation, neurogenesis, throughout their lives. So this is how microglia support neurogenesis. Microglia actively engulf dead or dying neural progenitor cells, apoptotic cells. Okay, so basically microglia are cleaning up this resident street. So they're the people cleaning up the waste and, also regulating how new things are being made. It's kind of like the HOA and waste management in one. Like, oh yeah, you can definitely make that. Go ahead. You can build that porch and please put your trash out on Tuesdays is microglia. Yeah, so they engulf dead or dying neural progenitor cells, apoptotic cells in neurogenic niches like the subgranular zone of the hippocampus. Microglia, they are cleaning up all the debris around the hippocampus. They're like, God, this neighborhood is a fucking mess. This prevents cellular debris from causing toxic inflammation and actually triggers a microglial secretome that supports surrounding stem cells. And they also secrete growth factors to encourage stem cells to survive, multiply, and differentiate into mature neurons. Microglia release beneficial neurotrophic factors. They also help with synaptic integration. Microglia help sculpt and prune developing neural circuits, ensuring that newly generated neurons form the correct connections with existing brain networks. Actually, they're not even like the HOA and waste management. They're like the best neighbors ever. They're like, they're just a community. They're coming together to, create community. They're cleaning up the waste. They're also like doing important initiatives in the neighborhood. They're also, pruning some trees, literally, or, making sure people flourish. And, let's connect you guys. I think that would make sense, right? And they also help with immunomodulation. Specific immune signaling can boost neuron growth. For example, research has shown that IL-4, interleukin 4, is part of the immune system, driven microglia promote hippocampal neurogenesis and aid in stress resilience in a BDNF dependent manner. If you're like, I don't know what BDF dependent manner is, it is totally fine. So basically, they protect the neighborhood, they clean up the trash, they're helping everyone grow and thrive, and they also connect people. I think that you would like that. And so again, this is what microglia are doing for hippocampus, amygdala, olfactory nerve, and then olfactory bulb is like outside. But like, this is what microglia are doing for this very deep-seated structure in the brain. And then hippocampus is crucial for spatial navigation and forming new memories. This is the lay of the land. And also we're making memories here. And then, new neurons here are integrate into existing circuits. Like neurogenesis, you make new neurons, you raise them, the microglia help tend to the neighborhood, can make new connections, and then you send the neurons on their way. Be free, go into the brain, learn, you're a memory, right? Sorry, I just spit. However, microglia can hinder neurogenesis. Like with chronic neuroinflammation, when triggered by prolonged stress, injury, or pathogens, microglia shift into an activated pro-inflammatory state. In this state, they release destructive chemicals, cytokines, that can inhibit neurogenesis and damage synapses. And also when you age, microglia can kind of inhibit neurogenesis. During the aging process, microglia progressively activate and secrete higher levels of pro-inflammatory cytokines, creating an anti-neurogenic environment that reduces neural stem cell proliferation. So they're like, I've done my work here. I'm inflamed, right? Like something from the environment. Like it could be like stress. The thing is microglia, like that's such a heavy task to support everyone
and clean up the neighborhood. And, you're asking them to do a lot. And then if there's like inflammation and you're just adding stress to them, they're like, what do you want me to do? And then also when you age, they're like, what was that? They're doing their best, but also chronic neuroinflammation doesn't really help them. And then also just neuroinflammation in general doesn't help them, and aging. If you want an abridged explanation of this, not really for all of this, I'd also recommend looking into the gut-brain axis and the gut-vascular axis. Love. Now we're going to circle back to the way beginning. Foam cells. They're not exactly like soap. They just look and act like soap and have a similar chemical composition formation process, but not soap. Hell yeah. Alzheimer's. Now, Alzheimer's happens because of a buildup of amyloid beta and tau tangles that are waxy or lard-like. With Alzheimer's disease, it is a specific form of brain amyloidosis. It is defined by the buildup of toxic beta amyloid proteins into plaques between neurons. These amyloid deposits disrupt cell function and trigger neurofibrillary tau tangles, which collectively lead to memory loss and cognitive decline. So, brain-specific amyloidosis requires beta amyloid plaques. It's the hallmark of Alzheimer's disease. It's an extracellular accumulation of beta amyloid peptide, specifically AB42, and also cerebral amyloid angiopathy, CAA. This brain-specific condition involves amyloid proteins building up directly in the walls of the arteries in the brain. It is frequently seen in Alzheimer's patients and can increase the risk of cognitive problems, sudden confusion, or stroke-like symptoms. Now, foam cells. Foam cells, which are, again, cholesterol-laden immune cells. And so we're talking about atherosclerosis in the body, right? It's a buildup of plaque, and you see like foam cells from macrophages, the immune system, in the arteries. Foam cells are increasingly recognized as a key player in the intersection of cardiovascular disease and Alzheimer's disease, where microglia, again, the brain's immune cells, consume excessive lipids from dead neurons or myelin. They can turn into foam cell-like bodies, which severely impairs their ability to clear amyloid beta plaques. The etymology for amyloidosis is derived from amyloid, combining the Latin amylum and Greek amylon, meaning starch, with the suffix oid, meaning resembling, and the Greek suffix osis, denoting a disease, condition, or abnormal process. It literally translates to a condition characterized by starch-like deposits in the body's tissues. Additionally, dehydration, often referred to as dry brain, is a serious complication for individuals with Alzheimer's disease that can rapidly worsen memory loss, confusion, and cognitive clarity. Why dehydration happens a lot with people with Alzheimer's is because in Alzheimer's, the part of the brain that signals thirst often degrades as Alzheimer's progresses. So I need us to take this all together. Another interesting piece of research came out this week that is going to drive my point home. Do not do this. Do not do this outside of a research context, and then even so, it requires much more testing before it can move forward in like any sort of medical setting. This is just interesting research. Inhaling high-dose CO2 clears Alzheimer's proteins from the brain. Intermittently inhaling a high dose of carbon dioxide seems to remove the proteins amyloid and tau, which are implicated in Alzheimer's disease, from the brain by boosting its lymphatic system. This came out July 20th of 2026, yesterday. So inhaling high levels of carbon dioxide intermittently for half an hour flushes proteins linked to Alzheimer's disease out of the brain. A small study has found. Small study, okay? Exposure to the gas changes how blood vessels in the brain constrict and dilate while we're awake, mimicking activity that occurs during sleep. That also happens, okay, I was going to say vasodilation and exercise and CO2, but I guess, yeah, okay. This then turbocharges the lymphatic system, waste clearing system, to remove the buildup of waste products that could cause harm. A 2025 study suggests the same approach could help with Parkinson's disease by clearing the protein alpha-synuclein. If you have any condition that is due to or exacerbated by any sort of accumulation of waste, this could be something beneficial. beneficial. Okay. The lymphatic system is outside the brain. The glymphatic system is inside the brain. The glymphatic system concerns waste clearance at night when you sleep. Your cerebral spinal fluid circulates around your brain. It's like little river canals, and it cleans your brain, does a little washing machine. It goes through like 90-minute phases that corresponds with your guts, your migrating motor complex. And I talked about this before. This was like another piece of research where I was like, I love this, where it compared the intestinal muscles to hydraulics with the brain, and how that the hydraulics of the abdominal muscles kind of move the fluid around the brain. I love this. Okay. So lymphatic system clears out the brain. Inhaling CO2 clears out the amyloid beta and tau tangles. It's a small study. Do not do this by yourself. Lard-like foam cells. Lymphatic system inhaling CO2. Do you know what carbon dioxide, CO2, does to actual soap? CO2 clears up and breaks down soap through a process called soap decomposition. The CO2 neutralizes its alkalinity. Soap is inherently a salt or a fatty acid, which gives it an alkaline, basic pH. When you introduce CO2 into a soapy solution, it reacts with water to form carbonic acid. This carbonic acid drops the pH of the solution and neutralizes the alkalinity of the soap. Because the soap molecule requires this basic environment to stay intact and hold fats, oils in suspension, the neutralization causes the soap structure to break down or cleave. So what happens when the soap decomposes? Fatty acids separate. The soap reverts back to its original fatty acids. Did you know that the brain is mostly fat? However, side table, we're getting too excited about the brain. This is about soap. When soap decomposes, the soap reverts back to its original fatty acids. Also, the foam and lather collapse. Without the intact soap molecules acting as a surfactant, which is a substance that lowers the surface tension of water, the foam and suds cannot be maintained. The foam and suds cannot be maintained. And this is just when soap decomposes. And then also, rinsing is easier. The degraded soap loses its ability to bind to water and dirt, turning the mixture into an easy-to-rinse, watery, and oily phase. So, soap decomposes, reverts back to its original fatty acids, and then the foam, the suds cannot be maintained. And then it loses its ability to bind to dirt and water, and turning the mixture into an easy-to-rinse, watery, and oily phase. Let's put these all together, lining up a parallel. Lard-like amyloid beta plaque and tau tangles, dry brain, and the cleaning system being cleared and utilized efficiently, effectively. And inhaling through your nose, CO2 breaks up the amyloid beta plaques and tau tangles. Do you know what these researchers have just discovered? Dry cleaning. That is not meant to be something that minimizes their accomplishment. What they have just done with CO2, breaking up these lard-like, starch-like plaques in the brain, that the glymphatic system can no longer clear, and it is dry, usually with Alzheimer's. These researchers have created brain dry cleaning. I understand that these foam cells and these plaques, it's not exactly so. However, the chemical process they are using to clear out these plaques is literally the dry cleaning process. Your brain is a very delicate tissue. What do you get dry cleaned? Very delicate fabrics. And this was just so cool. These researchers literally just discovered dry cleaning for the brain. And I know that it was a small study. They're going to have to keep testing it and testing it. Might I, any person from the study is watching this, might I recommend pairing up with someone in exercise science, because they have a lot of experience with CO2 vasodilation. I'm saying, like, if you're looking for like someone to like go run hand in hand, I'm saying like sports medicine. I mean, actually hematology, like really anyone, cardiologist, like this is just so cool. And so the thing is like, it's literally like, because your brain is like, so by not using the glymphatic system, which is basically like a washer machine, because the glymphatic system can't clear out this like very deep area in this very, this deep sort of buildup in this very delicate area. Literally, these scientists were like, fuck the washing machine. We have to go straight for dry cleaning. That's what they did here. Integrating mind and body. So cool. And this is why I'm obsessed with the lymphatic system. So I was reading that and I was like, just with everything I have been reading, and then I read that and I was like, ding, 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 ding. Oh my God, they made brain dry cleaning. That is so fucking cool. I also would say to the researchers, exercise science, hematology, immunology, all these other people, yeah, I don't know if this is a helpful piece of insight. It may help if the people you test on are a wee bit dehydrated. It may not work the same if they are well hydrated. Could they get lightheaded? Yes. But I'm saying it actually would help if their brain was a little bit drier. That's it for today, guys. Thank you guys so much for listening. I do have to say though, when it comes to sources, I will include all the sources that I can, but on YouTube, there is a 5,000 character limit. So if you're like, oh, there's sources missing, I can only do so much, and I keep going over every time. So if you would like a source to something, and I didn't manage to squeeze it in, even though if you look at all the sources for all previous podcast episodes, it's like, damn, Sarah, just DM me on Instagram. I'll shoot you a source, because Instagram is like where I actually answer DMs. But yeah, thank you guys so much for listening. Thank you for hearing me out. I'm sorry if this was so long. That was just so cool. I love smell and taste. And then I'm learning about the immune system, and to learn about a transplant gastroenterologist is like, yeah, like with transplants, you need to study immunology because like, you know, your body could reject it. And so it was just, she just like, oh, I love that. And then also I'd recommend Most Delicious Poison by Noah Whiteman. Whoa. I bumped the mic. And then The Human Brain book by Rita Carter. It is more like, it's not a textbook. Obviously, it's more like big book, similar to coffee table book, but like actually breaking down the brain. Thank you guys so much for listening. Make sure to like and subscribe. Rate me 5 stars on Spotify, Apple Podcasts, any place you get your podcasts. Subscribe to me on YouTube. Do show books and gesture, but you don't have to. This is a podcast. It's predominantly a podcast. So to be like, follow me on YouTube and then watch. Absurd. But like, thank you guys. And I will talk to you next week. I hope you have a good one. All things considered. The world. All right. Bye, guys.